Hello! Today we're going to look at solving trig equations like this, and with these limits out here. We'll come back to those limits in a second. We'll interpret what that means in a second. Let's not worry about it just now. So if we want to solve this equation here, we want to find out what x is. So let's get rid of everything else. Let's get rid of the 3, the 2 and the sign. So let's get rid of the 3 first. Let's subtract 3 from both sides. So subtracting 3 from the left hand side, we get 2 sine x. Subtracting 3 from the right hand side, we get 1. Now let's get rid of the 2. The 2 is multiplying sine x, so let's divide both sides by 2. So we get sine x equals a half. So now what we've done is we've simplified this little problem of finding x down to this. So we're looking for values of x where our sine graph equals a half. So let's draw, and we're going to do this in a couple of ways. The first way, we're going to draw a graph to help us. So sine graph, a little sketch, something like that. Maximum 1, minimum of -1. So what we're looking for is where sine x equals a half. So we're looking for that value there, and also that value there. So what we could do, we're going to use our calculator to help us. So to get rid of this sign, we do this thing called inverse sine. So inverse sine of both sides, let's get rid of the sign here. So in our calculators, we can do inverse sine of a half, and what we'll find is it should come out as 30 or 30 degrees. So in other words, that value there is 30 degrees. Right, we also want to find this other solution, but the graph, or sorry, the calculator doesn't give us that other solution, but we can use the graph to help us. So we know that this part of the graph, that little part there, is the same as that part there. So they're symmetrical. So in other words, the distance from there to there is the same as the distance from there to there. Well, this point here we know is 180, therefore that point there must be 180 subtract 30 by symmetry. So 180 subtract 30 is 150. So our other solution is 150. And if you're ever unsure about this and you do have a calculator, then you could put it back, the 150 and the 30 back into the original equation, or you can maybe just put them up into here. So sine of 30 will give us a half, and sine of 150 will give us a half. So one way of solving this trig equation is to use a graph. Next we'll look at using the cast quadrant. But before we do that, let's look at these limits. So we've got these limits. X has to be between 0 and 360. So in other words, our values of x have to lie between 0 and 360. So if we go back to the graph, this is our graph, the sine graph between 0 and 360. We tend to draw it between 0 and 360, but don't forget it can go on and on and on forever. So if we were to find other values of a half, so for instance if I extended that graph, I went on something like that, and I extended the half over to find the next value, that would then be 360. Actually, this part of the graph is the same as that part of the graph. Let's remember that. There's 30 in there. So therefore, this solution would be 360 plus 30, which is 390. And you can see that's out with our limits for x. So that's not a solution. Right, back to this equation and solving it using the cast quadrant. So when we get to this stage, we could use a cast quadrant instead of our graph. So what we do, we look and we see if the sign is positive or negative. Now it's a sine graph, and we'll look to see whether this number is positive or negative. It's positive. Therefore, solutions must lie there because they're all positive in there, between 0 and 90, all the graphs, and also sine is positive between 90 and 180, the S. It's negative in these quadrants, these two quadrants here, but it's positive in the all quadrant and the S quadrant. So the way they do this is we do inverse sine again. We'd get 30 degrees, so that's our solution here. If I draw a little line there, that's 30 degrees. And to get this second solution, what we do, trig's always based around the x-axis. And this thing we call a related acute angle. So we've got our first solution here, a related acute angle 30. So a related acute angle here we go 30 degrees away from the x-axis. So therefore our second solution round here is 150 degrees, or 180, subtract that 30. So two ways of solving the trig equation. You can use the graph or you can use the cast quadrant. Goodbye and thanks for watching.